Okay, this is the final video in our ROS2 series. So in our last video, we saw how to test our subscriber and our publisher standalone. Now we're going to show you how to set up a launch file. And there's several really good tutorials on the ROS2 website. This is going to be a kind of a fast overview of this. So I'm in my ROS2 workspace directory. And let's go ahead and look at that. I'm going to go ahead and move to my source directory. I'm going to move to my ID robot directory. I'm going to look at that. And notice there's a launch directory, and that's where we're going to go because we're going to look at our launch file. So if you look at our launch directory, there's a number of things here. What I'm going to look at is this my robot.launch.py. I'm sorry, Emacs, my robot .launch.py. And here it is. It's pretty straightforward. It's going to say we're going to create this launch file, and we're going to have 1, 2, 3, 4 nodes. And one of those nodes is the main subscriber node. One of those nodes is the OpenCV subscriber node. One of those nodes is the servo subscriber node. And one of those nodes is going to be the voice publisher node. By the way, you'll see that the nodes are very, very similar. It's pretty straightforward. What is my package? Where's the executable? This is without the .py. That's the way the system wants it. And then these are each of the node names. These are just used by the system. Now, one thing you'll notice is that the voice publisher is different. It has this screen on it. That is simply allows us to take and put information in that voice publisher to add debug information, and it'll output it to the terminal window. Again, just provides us with more information as we look at our code. And then we just go ahead and complete this, and now we're all set. And when we did the call cod build, that set everything up. So now what we have to do is actually run this. And again, because we have to use the microphone, and this is a connection remotely, we're going to look at a video from the Raspberry Pi. So let's go ahead and grab that. And we can take a look at that. Hold on. Let's see. Let's go ahead and grab that one. I think it's this one. So, nope, it's not that one. Sorry. Let's go ahead and grab this one. So this is the one. So again, we're all set up. Now ROS2 launch tells the system that we're going to run a launch file. So the MyID robot is the project, and the myrobot.launch.py is the name of the launch file. And sure enough, it went ahead. Let's go ahead and go back just a little bit, and I'll show you a couple of things. Oops, sorry, let's go back. So notice, what did it do? Well, it went ahead and said we have the login set to verbose. That way we can see all of the information we might want to print out. And then it went ahead and launched all 4 of our nodes and got them all started. By the way, a different way to do this, if we wanted to, is we could have opened up 4 different windows and used ROS2 space run MyID robot and the name of that node, and we could have had 4 windows each running their different process, and they would have communicated fine. However, this is kind of nice because we only need to type in the launch file. It's going to create everything for us, and then it sets everything up. And then what it does, what you're seeing here down here, is the debug information from our voice. So in this case, I said hello. It published hello. So it published hello. The servo got that information through that process and received it. Actually, this is interesting. So the voice publisher published hello. Main received it first. So the main subscriber then passed it along to servo, and then servo received it. And if we were actually with the device, we would have seen the arm move and gone to the home location. And then I said the voice command wave. Let's keep going now. So that got published to main. Main received that wave command. It then forwarded that wave command off to the servo. And then the servo received that message called wave. And again, if we were watching our robot, we would have seen it wave to us, go up and down using the servos. So this is how the system, we can invoke all of the different nodes. We could also have a launch file that invoked a subset of all the nodes. But in this case, we can then have all the nodes running without having to open up 4 or 5 or 10 terminals and typing ROS2 run for each of those. We certainly can if we'd like, but this again allows us to either run the entire system or a subset of the system. Notice in the end I said hello. That set the servo and the robotic arm back to the home location. So hopefully that's a pretty good overview, a little bit fast, about how to use ROS2 on a system. Now this was on the Raspberry Pi. We've also used it on the Jetson Nano. Any computer that can run the ROS2, this can work on. I have run this inside of my virtual machine before and had it work. So and again, anywhere we can run the ROS2, we can set up a system like this, set up our nodes, set up our subscribers, and the ROS takes care of all the timing and all the message passing, and again provides us with a really complete set of capabilities. Now, what I haven't talked about is ROS2's capability to add information or add libraries for additional capabilities. So oftentimes we can bring in nodes that other people have created, add them to our project, and then use that capability without having to write that code ourselves. So ROS2 can be a very powerful system to complete a robotics project.